Question number 86. The species produced at anode during the electrolysis of concentrated sulfuric acid using platinum electrodes. We are using the inert electrodes here and the process of electrolysis of concentrated sulfuric acid we are doing. So if we talk about at that anode, the reaction that's taking place is sulfate ion will move towards anode and they get changed into to OH2 negative ion and 2 electrons are released. This is the reaction that is taking place at anode, and on that basis we can choose option 3 as the correct answer. And after this there's a turn for question number 87. The molar depression constant of a solvent whose freezing point is minus 23 degrees Celsius and the latent heat of fusion is 125 joule per gram will be. It means you need to find out the molar depression constant Kf value for a solvent. Its freezing point is minus 23 degrees Celsius and the latent heat of fusion is also given, and that value is 125 joule per gram. For this we use the formula that is Kf is equal to R dF square upon 1000 L. And what is this L? This is latent heat of fusion we are talking about. What is the value of this Tf? This Tf value is equal to minus 23 degrees Celsius is the freezing point of the solvent. So the value for this Tf is 273 minus 23. It is 250 Kelvin. This is the value of Tf that we calculated. Now let's find out this molar depression constant. R value we already know, that is 8.314. Tf is 250 square divided by 1000. And what is this L value? This is 125. We have this value. And just solve this for the final value, final answer basically. It would be equal to 4.16 Kelvin kilogram per mole. This is the answer. And where this answer is given, this is given in option 1. And that's the final answer for this question. Now, after this, let's take next question. Question number 88. Ethylene glycol is an anti-freezing agent. The amount of ethylene glycol to be added to 2 kg of water to prevent it freezing at minus 5.58 degrees Celsius is. Kf value for the water is given 1.86 Kelvin kilogram per mole, and the molar mass of ethylene glycol is also given, that is 62 gram per mole. Let's solve this question. What we need to find out here, the amount of the ethylene glycol to be added to it. So we know that delta Tf is equal to Kf m, where this m is the molality of the solution. This can also be written as weight of the solution. So this is the formula that you can use here. Let's place the values here. The value of delta Tf we already know. In this case we know that here is the freezing occurs at minus 5.58 degrees Celsius. And in this case the solvent is water. So definitely this delta Tf value you can find out by considering that solvent is water and its freezing point is 0 degrees Celsius. Now 0 minus 5.58. Now this Kf value is already given in the question, that is 1.86 multiply W here, and W, that's a value that we need to find out. After this, molar mass of the solvent, that's also given in the question, 62 gram per mole, and then weight of the solvent taken is 2 kg. So 2 we have to take here in the grams. Now this would be equal to, we need to find out the value of W. This W will be equal to 62 into 2000 into 5.58 divided by 1000 into 1.86, and on solving this you will find out this value is 372 gram, and this value is given in option 4. That's why it's the correct answer. Let's take next question. In the coagulation of gold sol, which ion has the highest flocculating power? So just consider what this gold sol is. This gold sol is a negatively charged sol. And for the coagulation of negatively charged sol, we need some positively charged species, some cation. And the cation with more charge would have the more flocculating power. So in this case, we have to check only two cations are given here, Al3 plus ion and Ba2 plus ion. In these two, the charge on aluminium ion is more. That is why it will have more flocculating power. So in the given options, the highest flocculating power is there with aluminium ion. And that's why this is the answer that we should choose here. After that, there's the question number 90. The last question of the chemistry section. In Leclanché cell, the anode used is, if we talk about the Leclanché cell, in that case, the cathode that is used is graphite, while if we talk about the anode, that is made up of zinc metal. And on that basis, option 3 is the correct answer for this particular question. I hope all the questions, those we discussed here, are clear to you. All the best for your results. Thank you so much for watching.